Okay. It is very important that after the lecture, guys, once you get access to my math lab this afternoon, I want everyone to know that you're not expected to learn everything right after the lecture. Like it'll be amazing. Best case scenario, you learn the lesson with me in class. You're like, okay, I get this. I could do this on my own again if I had to. But then there's some people who after the lesson, it's still not clicking. So in order for you guys to really, for it to the material to really click in, you have to devote some of your free time where you can find it working on practice problems on your own, doing the assignments for my math lab with your by yourself or with a group of students from this class. You want to expose yourself by trying to do things on your own and struggle too. Struggling is part of the process. Now, I'm saying struggle. I'm not saying torture. If you're torturing yourself over a problem because you're lost or you just really don't know how to tackle it from where you're at, that's when you need to know when to ask for help, when to push through. Okay. And that's what you're going to learn in this class is, okay, I'm picking these things up. This is, I'm not picking up, and you got to devote some of your time. Now, that means you may watch other videos of people solving the exact same type of problems. You may do other practice problems. The beautiful thing about my math lab, once you get access to it, is you have the textbook online and the homework assignments that I assign you, you can ask for a similar problem. So I'll give you a different numbers, same concept, and you just have to try it out on your own by solving it. You know what I mean? So you want to do that. It's like when you start a new sport or hobby, you're not a pro when you start. You actually are a beginner and you get better through time, commitment, and practice. And unfortunately, mathematics is the same way, y'all. I cannot tell you how many times and hours of my life I put into this subject over the years of my education. I would, yeah, I would work and I would work full-time job, part-time jobs, full-time jobs, and go to school. You have to, it's going to be tough, but it's going to be worth it at the end once you build your
Okay.
knowledge. All right. As I understood, guys, before we begin.
Yes.
Yeah, because I had some students like talk to me and be like, "Sir, I still don't get this. I don't know. I need your help." And I had to sit down with them, tell them like, did you try practice problems? Did you
Mhm.
watch other videos? What did you do to get better? Oh, nothing. I was waiting to tell you. Oh, I'm like, yes, I'm here. I'll answer any confusion you may have, but I cannot hold your hand the entire semester. You have to take initiative and try things.
Okay.
And they were kind of upset, because they're like, well, you're a professor, I'm paying. Yes, I get that, but you have to understand that I have other classes, other students, and other responsibilities, just like you do. Y'all have other classes and other responsibilities. We have to learn our best to work together with what we have. So I am going to add a discussion post on Canvas sometime this week where you're going to write about yourself, like who your name is, your nickname, you have kids, if you have a job, what are your goals for academically, what are you trying to push for, like what are you trying to become, and have everyone else doing it. That means you get to meet your classmates in this class, and maybe you can reach out and be like, hey, I saw that you're doing this and I have kids too, you should study Pacheco's class on Sundays. What do you do on Sundays? Oh, I go to church, but I'm free afterwards. You know what I mean? Like I want, and it doesn't have to be a physical hangout. It doesn't have to be a Starbucks at the library. It could be virtual. Since you guys are PAC students, you guys get free Zoom. Well, not really free, right? Because you're paying for school, but it's embedded in your tuition. So take advantage of the resources this school offers. And there's a My Math Lab, guys. PAC has a Math Lab tutoring center where you can go in person since you're a student and take your laptop and your notebook from my class and sit down and be like, hey, I need help with these problems. And someone else will be able to explain it to you as well, free of charge. You don't have to pay for someone to help you. It's like it's in your tuition. So I want you to utilize your research because I remember when I was a freshman, I was living on campus. I was at the library or the tutoring center, library or tutoring center or the cafe. So I'm encouraged. This is not like an attack. This is not to make anyone feel inadequate, but these are words of affirmation and encouragement of what can be done to improve yourself as a student. All right. Now, before we begin, were there any last minute questions from last lessons where we talked about exponents, exponent notation, order of operations, and solutions of an equation? Make sure you're looking over the notes again. If you weren't here last class, make sure you take your time to write the notes on your own. And then I'm gonna try to establish some tutoring times throughout the week, when I could meet up with you guys virtually. If I remember on campus, I'll let you know, hey guys, I'll be on campus in this room, from this time we want to show up to work together on assignments and stuff, or online, or we could be a virtual hangout as well, where we all log on, work on our homeworks, ask me for help, and we're just kind of just working together. You see what I mean? So like I just things I want to start to do as the semester progresses. All right, let's begin. Welcome to lecture 2, guys, with elementary algebra with Mr. Pacheco. Let me go ahead and move this over. All right, I'm gonna go ahead and give you guys about 2 minutes to set this up in your notebook. 2 minutes. So yes, we have wrote these steps already again, but we are doing it again. Whatever is on my presentation, you will write it, guys, for your benefit. All right, guys. If you're still writing, don't worry. I'm just going to read over these steps as we get started. All right, so we're doing 2.5 order of operations. Well, in the last class, when we did order of operations, it was kind of more like an intro lesson. It was kind of getting used to how we do the order, how parentheses works, how we evaluate exponents, how we multiply or divide first, whichever one comes first from left to right, and then add and subtract from left to right. Now we're gonna add a twist to today's lesson, guys. We're gonna have different types of numbers. We're gonna have positive and negative values. Now, before we jump into the lesson, guys, I want you to write something onto your notebook. You're gonna write this for me. You're gonna write a positive times a positive will always be a positive number. A negative times a negative will also be a positive number. A positive times a negative will always be negative, and a negative times a positive will always be negative. Go ahead and put that in a box. Until you remember this behavior, I want you to write this box in every page of every notes that we move on in your notebook. so that we don't have to, you don't have to flip your notebook back. And you can just write in the corner somewhere on the very top of your notebook. You know how there's at that top space of your paper. You can put that on there every page you write until you remember these properties. So let me break down the properties for you. So this is for multiplying. It's for multiplying and dividing integers. Integers are positive and negative whole numbers. So remember this, when the numbers are both the same sign, when we have a positive times a positive, it's always going to be positive. When we have a negative times a negative, it's going to be also positive. So when the signs are the same, it's going to be positive. When we have one positive and one negative, it's always going to be negative. Do y'all see that? A positive times a negative is negative, and a negative times a positive is a negative. So remember this behavior, guys, because as we move on, you're going to use these properties throughout the entire lesson today. So look at number one. We're going to find the value of each expression. So look at number one. We have -3 in parentheses squared. So looking at number one, what number do you think is being squared, guys? The 3 or the -3?
The
What's
negative 3.
the -3? Because it's in parentheses. So we're going to write equals, and it's going to be multiplying to a -3 times another -3. So we have a negative times a negative. So what's a -3 times a -3 going to equate to?
Positive 9.
A positive 9, and we are done. All right, number two. Number two is -3 squared. So what we want here in number two, another way to write number two is we want it to, the answer is going to become, we want the negative of 3 squared. We want the negative of 3 squared. That's what we want in number two, which is different from number one. You see how they're different? The negative is in the parentheses and this one's outside of the parentheses. So we want the negative of this. So this would be the negative of 3 times 3. What's 3 times 3?
9. Positive.
It's a positive 9, but what's in front of the parentheses?
Negative.
So it'd be a -9 at the end of it. Because you know how in Pemdas we have to do exponents first before we multiply? So we had to do 3 squared first before we multiply the negative in front of it. Number 3 is pretty simple. It's 2 times 5 squared. So 2 times 5 squared, it's going to be 2 times 5 times 5. What's 5 squared?
25.
What's 2 times 25?
Mm, 50.
And we are done, ladies and gentlemen. Now, what questions do we have so far from these first examples? No worries, Josh. We just started, sir, and I am recording this lecture. So, and I have to make a YouTube channel since I can upload all my lectures on Canvas. So just be prepared for a YouTube channel, guys, for my lectures. All right. What questions do we have so far before I move on?
None.
All right, let's go. So now before we move on into your first practice set, I want you to rewrite this helpful hint in your notebook. This is a big one because the reason why I'm having you write this again, this hint, is because I had a lot of students that get confused with the negatives. So this is why we're adding this helpful hint in our notebook. I'm gonna give you guys about 2 minutes to set this up. And I'll add more time if y'all need it. Good luck. All right, guys, my toddler's gonna chill in my room in the background. So I'm gonna turn off my camera because he's in his diaper, and I'll turn it on once my mom finishes showering. So I'm still here. I just don't want you to see a random baby. All right, would anyone like an additional minute or two to finish copying this helpful hint?
Yes.
Okay, 1 or 2.
2.
All right,
Yeah.
I got you. All right, guys. All right. I'm gonna go ahead. All right. So before we move on, guys, we got to recall, look at the helpful hint. When simplifying the expressions with exponents, remember that parentheses make an important difference. So, and let's try to make a pattern from it. Whenever it's a positive, a negative inside the parentheses and we square it, Well, two negatives we know makes a positive, so it'll come out positive. Whereas the negative 3 squared without the parentheses, what is the opposite of what 3 squared is, which is the opposite of 9 is -9. So then we do, so that's what pretty much breaking down the differences, all right, is understanding what the parentheses do to a number or an expression. Here's your first set of practice problems, guys. I'm gonna go ahead and give you guys about 4 minutes to work these out. Good luck. All right, guys, that was a 4-minute timer. Anyone want to share what they got, or y'all want me to go over these? How does everyone feel about 1, 2, and 3 so far?
Good.
Good, good, good.
Maybe a number 3, if you could go over that.
Cool. Sounds good. So number 3. All right. Well, what'd you get for 1 and 2?
16 and negative 16 for number 2.
Excellent. Good job. If you didn't get those, double check your work. On number 3, it wants 3 times 6 squared, which is the same thing as 6 times 6 in parentheses. 6 times 6 is, I believe, 36.
Equals 108.
And equals 108. That's correct. Excellent. Good job, guys. Are there any questions or anything you want me to work out for these practice problems?
Kind of messed up with number 1 because I think I did have it right. I think I second guessed myself because I did have 6, but I think I kind of did wrong.
Let's find out. Let's see what happens. So -2 to the 4th, the base, since it's in parentheses, we're going to multiply -2 to itself a total of 4 times because of the exponent 4. Everyone with me on that?
Yes,
So now remember the integer sign, guys. A negative times a negative is a what? A positive 4, right? So we still have the 2 other -2's to mess with. Now we're going to do 4 times -2. Well, positive times a negative is a
Negative.
negative. Excellent. -8. And we still have 1, 2 to multiply. So now we're going to do -8 times a -2. 2 negatives we know makes a positive, and then 8 times 2 is 16. This is how we get positive 16. Did that explanation help you out, Melanie? Excellent, excellent. Any questions for anything else before I move on, guys? I didn't do number 2. Is everyone okay with the concept of number 2? All right, I'll take the silence as we're all good to go. Let's move on. Here is example. Next examples, we have 4 in this slide, right? I'm gonna go ahead and give you guys about a minute to set up A and B first, and then we'll do A and B, and then I'll give you a minute to write C and D down, okay? And it's not gonna be that many steps for A and B, but make sure you do write Pemdas somewhere into the side of your notebook. So I'm gonna do P, if it's a new page, of course, but I want you to make sure you can see the steps as we work through them. All right, let's look at example A. Now, remember, we have a fraction here, right? A top and a bottom, where we have to simplify the top, simplify the bottom, and then divide the two, because a fraction is another way to write a division problem. All right, let's get into it. Now, before we jump in, remember the positive and positive. Whenever you're in a new page in your notebook, write out this box in each page as you get onto it. So that way you can reference this and not have to flip through your notebook. Yes, it's annoying, but eventually you're gonna write this so many times, it's gonna become very intuitive and be like, oh, that's that, you know. So let's look at A on the top part. On the top part, we're gonna multiply -6 and 2 because of the parentheses. This is a multiplication problem. Can y'all tell me what a -6 times a +2 will equal to? A -12. That's correct. Now, do we have to simplify anything else with the bottom?
No.
So just bring it down. So now we're dividing -12 over -3. Well, two negatives, these
It's
two
a positive.
is that become a positive. And how many threes go into 12, y'all?
4.
4. And so the answer is positive 4. And we are done. What questions do we have so far for A, if any?
None.
Excellent, guys. Let's look at B. All right. 12 minus 16 over negative 1 plus 3. Now we're gonna be messing with positive and negative numbers, class. And I want you to understand something. I'm gonna show you and explain to you how I teach adding, subtracting positive and negative numbers with the one concept most of us should be exposed to at this point of our life, and that is money. We've all made money. We've all spent money. We've all gotten paid. We've gotten money from people, and we all spent money on our bank accounts, cash, whatever. So we know adding and subtracting, right? So look at B. 12 minus 16. 12. That's a positive 12. So would you say if you saw a positive 12 in your account, would you say you have $12 in your name, or do you owe the bank $12?
You have $12 in your name.
You have 12. The minus 16, is that you spending $16 somewhere, or is that you getting 16 into your account?
Spending.
Spending, because it's a minus. So if you had 12 bucks in your account and you spent that 16, what are you going to owe the bank, ladies and gentlemen?
Negative
A
$4.
negative number.
A negative number. Yes, a negative 4. Excellent. Is everyone with me on how we got negative 4?
Yes.
Now, if you don't understand that, use your calculator, do 12 minus 16 and see that you get the negative 4. So then it's going to be over.
2.
Excellent, because negative 1 plus 3 is 2. And now we're dividing a negative and a positive. A negative and positive is going to give us what kind of value?
A
No.
negative two.
A negative 2. And we are done. I'm going to go ahead and give you guys a minute to copy down C and D down so we can work those out as well. Now, the first two didn't really require us to use Pemdas since there was only one operation. Like A was only times on top, and then B was minus on top, plus on bottom. So it's C and D that we're going to really have to be careful now since we're going to be using Pemdas now. All right, let's look at C. So C is 60 plus 30 plus parentheses negative 2 cubed. So before we work out that one, I'm going to show you what we do whenever I have my math homework and I'm working on my stuff. I don't always like to do like the stuff that I'm multiplying on the paper where I do my steps. Off to the side, I write the word scratch. This is what college professors do. So scratch is where we pretty much work out any little tiny math that we don't really want to include in our process. So Pemdas, parentheses. There's no parentheses with us to simplify something. Exponents, negative 2 cubed. So I'm going to use this scratch section to evaluate what this is. So for negative 2 cubed in parentheses, we're going to multiply negative 2 to itself 3 times in total. Because that's what that is, correct? So let's
Yeah.
multiply. Negative 2 times negative 2. Two negatives make a
Positive.
Positive 4.
4 times negative 2 is a
8.
what kind of 8?
Negative 8.
Negative 8. So now exponents is done. Now we know it's going to be 60 plus 30 plus a negative 8 in parentheses. Now I want you to remember that we know the parenthesis symbol also means multiplication, correct? So I want you to look at something. Look at this plus negative 8. I'm going to tell you this as a fact, and I hope that you follow with me. A plus a negative is the same thing as plus and negative here. So we can combine these two plus and negative and get a what kind of symbol?
Subtraction.
A subtraction. So in the next step, guys, I'm going to bring down the 60 plus the 30, but instead of plus negative 8, this is the same thing as minus 8. Those two combined gives us a minus by using the chart that I'm having you copy in every page. Is everyone with me that these mean the same thing?
Would it be 82?
Let's go ahead and figure it out. 60 plus 30 is
90.
90 minus 8 is 82, and we are done. All right. Now let's look at D. D has -4 squared plus parentheses -3 squared minus 1 cube. So we're gonna have a lot of scratch work, right? Because there's no parentheses for us to simplify. So let's do some scratch. The first thing we're gonna simplify is we're gonna figure out -4 squared. Well, the
Positive
parentheses.
16.
Go ahead. What did you say?
Positive 16.
Ah, you sure? Remember, you were not squaring -4 because it's not in parentheses.
Negative 16.
-16 because we're asking for this. We're asking for -4 times 4. And 4 times 4 is 16. So we get -16. So that's what this first one is equal to. Now we're going to do -3 squared in parentheses. So what's the base going to be for this one?
3. Negative 3.
It'll
3.
it'll be a -3 times another what?
-3.
Which gives us a what kind of value?
Positive 9.
That's correct. And then the last one we have is 1 cube. 1 cube is just 1 times 1 times 1, which is just what? 1. So we're gonna put all this scratch work now and come and add to our expression. So instead of -4 squared, I'm gonna write what?
16.
Yep, -16 plus, right? Bring down the plus sign, and we know -3 squared is what kind of 9?
Plus 9.
Plus 9. And bring down the minus sign, right? Because it's not -1 in parentheses, it's just minus whatever 1 cube is. 1 cube was 1, so -1. Does everyone see what we did from the first step to this step using the scratch work? We found out what those exponents were and then replaced them in the presentation. So now Pemdas, we now have to add and subtract from left to right. So -16, y'all. Do you owe 16 or have 16 in your account?
You owe 16.
You owe 16.
But how much did you put? How much did you get from work, from tips?
$9.
So now what do you owe the bank when you combine these two?
About -8. No, you actually owe about -7.
-7, you still owe them, right? But then you saw a deal on your favorite snack at the gas station. There was another dollar you spent, right? I know we have a bad habit, but now what do you owe the bank?
Negative $8.
Money, and we're done. Be honest, guys. Does the system of money really help with that and subtracting, or is it throwing you guys off?
It helps.
Okay, cool. Thank you. My high school students were beasts at negative and adding negative and positive numbers because of money, and they use money now because they're teenagers, you know. So I'm glad you guys comprehended too. Okay, cool. All right, ready for your own practice problems? Good luck. Here's your first 4. Here's number 1, number 2, number 3, and number 4. I'm gonna go ahead and give you guys. I'm gonna give you guys 6 minutes. All right. Good luck. If I need more than 6, I got you. And y'all can. I've had the other class where they were typing their answers in the chat and kind of help each other out. Hey, I got this. Oh, I did this. It was pretty impressive. So feel free to do the same. No pressure though. Good luck. What did you get for number one, Sean? So we have some people, so some students got +5, some people got a -5. All right, guys, that was my timer. Is anyone still working on any of these problems, guys?
I'm on the last one.
One number three.
You want me to add like, I'll add an extra 2 minutes, 2, 3.
Yes.
I'll add another 4 minutes, make it an even 10. All right, good luck, everyone. And after 4 minutes, if I can have a student volunteer to present, not present, but explain what you did for number one, I would like a different student for number two, and to just talk out about your steps and how you did it, so other students can hear how you're breaking it down. Okay, guys? Good luck. And if you finish early, feel free to get up, stretch, get some water, you know, like you can move your body around because I know how it's like to be sitting down. Yes, I completely agree, Jennifer. And the way I set up the structure of the examples and practice problem is very similar. This is the way I learned. I learned with professors lecturing me examples and pretty much just after he does examples or she does examples, they give us practice problems on the assignments. But see, I'm not gonna just I'm not I didn't want to just teach here. I wanted to teach and let you practice with me and with each other, as opposed to you guys working online. So this is the difference I'm adding to it. Will I be able to do this every class period, every lecture? I'm gonna try, but if you start to fall behind, you'll see less practice problems and more examples of me giving you. But I'm gonna really try my best to incorporate practice problems. Now, in case I cannot add practice problems because of timing, because I don't want to, I want to make sure I can cover everything I need to before you leave this class. Worst case scenario, I'll do the lecture, and if we have any time at the end, we can do all the practicing at the end. Worst case scenario. But right now, I'm able to embed it for now. But there's gonna be some weeks where I have to do a lot of sections, and I'm like, oh, I don't know if I can practice on those things. But we'll see how it goes, right? It's my first time teaching a flex course. I'm comfortable with 16 weeks courses. 18 weeks is a little overwhelming, but we're gonna make this. We're gonna make this happen. So number one, can someone explain what they got for number one and what they did? Because we have some students who couldn't get started and they were stuck on number one. Monica?
I got +5.
Okay, how did you get that +5?
The answers were -5 and -25, and you divide those two, and a negative is a positive.
That is correct. Good job, Monica. Good job. All right, we do have another volunteer for number two.
I got -12 and then -4 as my bottom number. And then I divided it and then I got +3.
Ah, good. So get the +3. Good job. That is correct. Vicky, you didn't see the -1? Okay, so now you see why it's a positive and a negative, not a negative now. You're good. And that is correct. Yes. Number two is a +3. Good job. Do I have a volunteer for number three?
So that one was a +3.
I got again, I did parentheses -4 times parentheses -4 times parentheses -4.
And what
then
did you get?
I brought it all down to 30 plus 50 plus parentheses -4 times -4 times -4, all parentheses. And then I did 30 plus 50 minus 64 because the positive and the negative mean subtraction when they're next to each other. And then I got 16 positive.
And that is correct. Good job. Did anyone else not get 16 and want to talk about the mistake they made? Because what if someone else made the same mistake, but they don't want to speak up?
I didn't even do it, to be honest with you, because I got lost after the 30 plus 50 plus minus 64. And then I didn't get to finish it. But,
So you froze. But now that you heard her process, does it click better on what you should have done after that now?
a little bit, because I'm still getting, I'm gonna be honest with you, I'm a little confused. I'm writing my problems as neat as I can, but like you said, do your scratch on another sheet of paper. I'm just losing myself a bit, I'm gonna be honest with you, because the numbers are just coming at me.
Yeah, and take a deep breath. Yes, when it's a bit overwhelming when you see all these operations, especially if it's been a while since you thinking like this and doing stuff like this,
Oh,
right?
it's been a long time for me.
Of course, it's like if you never worked out all year and you go work out with someone who works out every day, you're gonna be sore, you're gonna be struggling. You're not gonna be like the other person who goes every day. So that is normal. Now the question is, what are you gonna do not, you need to find coping mechanisms, take deep breaths, be okay, this is my worksheet, this is my notes, this is my scratch work, this is my notes, this is for my, you know what I mean? Like you gotta keep it organized and not freak out. Like you can, I do the scratch work on the same piece of paper,
Mhm.
just close by, you know?
Yes.
So look at number 4. Did anyone tackle this one? Let's see if anyone will actually share number 4.
Okay, I got 9, but I'm pretty sure I did it wrong because I don't know, I kind of got confused as well because there's a lot of numbers and all that. So I did negative.
So what'd you get for -2 cube?
I got -8.
That's correct.
And
What
then
what'd you get for -4 squared?
I got positive 16.
That's correct. What did you get for 1 cube?
Positive or +1. Yeah, positive 1.
That is correct.
Oh, okay.
Now you add and subtract from left to right.
I got positive 9 because I did 8 plus 16, and then I got positive plus negative, which is a negative.
And you are correct. Now, does anyone need any help on simplifying these exponent parts? Does anyone need me to show you the work for that? Or is everyone okay with that?
I think I do need a little bit more help.
Okay, let's take a look, okay? So I'm gonna show you, so I'm gonna see it's in the same paper. If this was my notebook, I would just write the word scratch over here to the side. And then let's go ahead and look at it. So let's do -2 cube. Now remember, if you have to go back to your notes and look through your notebook, you can. That's why we do all these examples, guys. That's why we do these practice problems. So it's just like number 2. There's no parentheses. So we know the final answer is going to be what?
-9.
Negative, right? So we go back to this
Mhm.
over here. No, right here. So we have -2 cubed. So we know the answer is going to be negative, right? So it'd be negative parentheses 2 to the third, which is just the same thing as negative parentheses 2 times 2 times 2. Now let's multiply that. 2 times 2 is
Or
times another 2.
8. 8.
8. So then we have, but what needs to be in front of this 8?
negative.
A negative. So we're done with the first exponent. Now we're going to do -4 squared. Ah, the -4 has the what, ladies and gentlemen?
Parentheses.
Parentheses. So it's going to be -4 times another -4. Now remember the hint that we wrote in our notes, the hint. Hint says -3 squared. We multiplied the 2 negatives in parentheses. Remember, everything that I'm making you write in this lesson is for your own benefit, okay? So now a -4 times a -4, 2 negatives make a what?
Positive.
Positive.
And then 4 times 4 is 16. So that's why it's plus. We bring down the plus sign and we know this part is equal to 16. So now we're on the last exponent, 1 to the 5th. We know 1 times 1 times 1 times 1 times 1 is just going to be what?
1.
1. So that's why we put 1 plus 1 there. And there you go. Yes,
I have a
Monica.
question. Okay, sorry, I came in late. I apologize for that, but I need you to back up a little bit. So with the negative outside the parentheses, we add the negative afterwards to the answer.
Yes.
Okay, and when the negative is inside the parentheses, it's being added as we go.
You're going to add, yeah, it's going to be a part of your base. That is correct.
Okay, that's where I was getting kind of confused.
Okay, good. I'm hoping
Okay.
this clarifies the confusion.
Yes, it really does.
Okay, and then were you able to come into the lecture to get this helpful hint written down?
No.
And that's okay. That's why I'm recording the lecture. So,
Yeah,
so if let's say we went through a lesson and you're doing the homework and it's just not clicking, I recommend rewatching the portions of the lesson you need to relook. I'll be honest with
Yes.
you, I'm also a student now. My professor records his lectures, thank goodness, and I probably rewatch this stuff 2 to 3 times. And it's kind of annoying because he talks pretty slow, but I'm doing it because I want to see him explaining, and it makes a difference. Okay, so I urge you to do the same. Okay.
I am definitely doing that. And I also need to ask questions about the math lab because I'm very confused on some of that stuff.
We're gonna, are you able to get on, Monica? Have you got?
Yes, I was able to get on, but because I'm not understanding the direction, I'm missing some questions.
Definitely, and we'll take, and you can ask me. Hopefully we have time after the lecture today to go over my math lab, okay?
Okay.
All right, let's keep going, guys. So we have 3 more examples, but they're a little bit more complex. So do me a favor and do one at a time. Let's go ahead and write down E first. And then we'll do F. And then G.
I have a question about my math lab, if that's okay.
About what?
My math lab,
Yeah, what about it?
I still don't know my access code.
We are gonna hopefully, if I can finish these lectures before class is over, I'm gonna use some class time to make sure all of us can get access to it this afternoon. I'm gonna try to show you the steps on how to get on, and then while everyone's doing that, I'll help Monica out with her questions on what you're struggling on, just to make sure y'all get the help that you need. And keep in mind, guys, that PAC does have a free tutoring center for all math classes available to all students. All you gotta do is just show up on campus and I think have your student ID, and they'll tell you how to sign on, and you can have a free personal tutor to help you out throughout the problems and explaining things to you, whenever I'm not available. But I am gonna try to put on some tutoring set times for you guys each week, and they may be different each week since I have other responsibilities, but I will try to be flexible.
What if we don't go to Palo Alto?
I think you can go to any Alamo colleges.
Okay.
Yeah. As long as you're a student and you have your study, you can go to, and every community college on Alamo has a math lab, so, or tutoring center for math. So you're eligible to go to either one, whichever is closest and convenient for you. All right, let's look at G. I mean E. So remember the order of steps from Pemdas. Remember the integer stuff. So I'm gonna go ahead and write the Pemdas steps here. E. Are there any parentheses with us being able to simplify inside?
Yeah.
Yes.
Yeah, the 4 minus what?
7.
7.
So you have $4 in your account, right? And you spend 7 because it's a minus 7. How much are you gonna owe the bank?
-3.
-3.
-3.
That's correct. Now, guys, we have a plus a negative right here. Can y'all tell me what operation is this gonna simplify to the plus a negative?
Subtraction.
It's a subtraction. So we're gonna write -2 -5 and bring down everything else. So we are done with parentheses. Are there any exponents in E?
No.
No, we're done with step 2. Now, do you see any multiplication or division in this expression?
Yes. 3.
Yeah,
No.
time 3
3
times.
3.
What's 3 times -3, y'all?
-9.
So we have -9 -2 -5.
I got -16.
So now now that we're done with multiplying, let's add and subtract. We get -9. So if you owe the back $9, guys, and you spend an extra 2 and an extra 5, how much are you gonna owe them at the end of the day?
-16.
And we are done.
I think it looks harder because there's more numbers.
There's more numbers, guys, and the numbers are now different signs. Last lesson, they were all positive. Now we're throwing a lot of negatives in there. And it's kind of forcing your brain to think about the idea of positivity and negativity. And that's why I'm using the concept of money to help break it down for you, okay? And I'm sorry if it's confusing you guys, and for just ask me to explain it, and I'll try to explain it again differently, but try your best. That's all I can ask, okay? All right, y'all ready for F?
Yes.
So we have the absolute, we have not absolute, we have -3 times the absolute value, guys. You see these straight lines, that's an absolute value. So we're gonna make our a note for this example. So write note onto the side somewhere. And write the absolute value of a number will always be positive. Like for example, right, EX, the absolute value of -7 will be 7. The absolute value of +7 is also 7. All right. Now that we know the absolute value, we're gonna go ahead and simplify that absolute value so the symbol goes away. Can y'all tell me what the absolute value of -5 is gonna be?
Positive.
+5.
+5. So let's bring down everything else, guys. Everything else. So now we have a minus, a negative. So remember the symbols. If we have two negatives next to each other, it becomes a what, guys?
Positive.
A positive. So right here, these two
Positive.
minuses are going to become a plus. So we're going to write +2 + 4 squared. Bring down everything else. Notice how we're cleaning things up. We have less math symbols and it's becoming nicer. Now let's apply the Pemdas to simplify. So there's no more parentheses to simplify. So we're done. Are there any exponents?
Yes.
Yeah, what's 4 squared?
16 positive.
+16. So bring down everything else.
15 plus 2.
Now, do you see any multiplication or division?
No.
You
Yes.
sure? Yeah, we're at.
3 times 5,
What's -3 times 5?
Oh, I forgot.
15.
15.
What kind of 15?
-15.
Negative 15.
-15. So now we're done with multiplying and division. So now we're just gonna add and subtract from what? From left to.
Right.
So do you have 15 or do you owe 15?
You
We
owe
owe 15.
And then how much did you put in your account?
$2.
And
16.
so when you put the $2 in, now you owe the bank how much?
$3. Oh,
Once
wait.
you
13.
you owe them 13. After you put the 16, now how much positive do you have?
3.
3.
Oh, no.
Now let's say that this step confuses you. How do you do this? Get your calculator, plug in -15 plus 2 plus 16. You do not have to be a human calculator to be successful in this class. Use the resource when you need to. Is that understood?
Yes.
All right. G. Which one would you do first, guys? C and G. Are you gonna do the brackets or the parentheses first?
How was the parentheses?
The parentheses, right? Because to do the bracket, we need to know what that parentheses is. So -1 plus 6 simplifies to what? You owe the bank $1, but you got $6. How much do you have when you put in the 6?
5.
Now now we have to do yes, it is 5. Now we have to do Pemdas inside. So to do Pemdas inside, are we gonna multiply the 2 and the 5 first? Or am I gonna add the -3 and the 2? What's first?
I'm sorry, what was the question?
The question is, are we gonna add the -3 and 2 first? Or are we gonna multiply the 2 and the 5 first?
1 and 5.
The 2 and the 5. What's 2 times
Add.
5?
And
Ah, someone said add. Look at PEMDAS. What's first, M or A? M. So we multiply first. 2 times 5, which is 10. Is everyone with me?
mhm.
So now we can simplify the brackets, everyone. What's -3 plus 10?
-3 plus 10 is
7.
7. Now, ooh, what's happening with this -2 and 7? Am I gonna subtract these, add these, multiply?
multiply.
We're gonna multiply. What's -2 times 7?
Positive 14.
Positive 14. Wait, -2 times 7? No, it's not positive, right? Because it's negative and a positive. It's a what kind of 14?
Oh, -14. Sorry.
No, you're good. You're good. You're good. My bad for not thinking about it. Now, -14 minus 5. What's gonna be your leftover balance when you owe 14 and spend 5 more? I heard positive 9.
-9.
-9.
Negative what?
I thought it
9.
I thought it was,
Wait.
Yeah.
-9?
oh, a positive. Positive 9?
Let's read the expression. Do you have 14 or do you owe 14?
-19.
-19.
-19. Because you owe the bank already 14 and we have a money problem. We're like, hey, I need 5 more. And you spend the 5. So you owe more. You're gonna owe 19, not 9. Is that understood?
So
Yes.
Yes, it does.
All right. Any questions before you practice on your own, guys? Any questions? Everyone okay with absolute value? All right.
No.
Remember,
sorry.
Rosemary, the absolute value of a number will always be what kind of number, Rosemary?
Positive.
Oh,
Always
okay. Yeah, I
positive.
have that down here.
Okay, good. Remember, use your notes to help you apply the steps on the practice. Ready? Here is your next set, guys. Good luck.
so when you owe like negative and negative, the number's gonna stay negative, right? Unless it's a negative and a positive.
Yeah, it depends on the situation. So you're talking about the last one when it was
Yeah.
-14 minus 5, right?
Yeah.
Yeah, so -14, think about the money. Do you have the 14 or do you owe the bank 14?
You owe it.
And then when you have a -5, are you spending more money or are you getting money from somewhere?
Spending it.
So if you're spending 5 more and you already owe the bank 14, you're gonna add the 2, right? But since you owe the bank, what kind of number is it gonna be when you add them?
Negative.
That's correct.
Okay.
Great question. All right, guys, there's your, I'm gonna give you guys, yeah, let me go 9 minutes. I'm gonna do 9 minutes. I'm gonna give you 3 minutes for each. Good luck. Use the chat, use each other. Good luck.
I have a question. See there?
Yes.
Okay, so for number 2, I'm confused on, I know that an absolute number, it's always positive, but whenever it's plus negative, isn't negative subtraction?
So you're talking about plus negative right here, right?
Mhm.
Yeah, this is gonna become a what? A subtraction. That's correct.
Yeah, okay. Okay.
Sir, I have a question about the lab.
What's up?
Do we have to pay to get that?
No, it's in your tuition.
Oh, okay. Well, never mind then.
So, hey, Alex, and after this lecture, hopefully I can finish up after we have one more section after this. Hopefully we will have enough time for I can go over the steps with you, okay? To get your
Okay.
access, okay?
Okay, thank you.
Oh, thank you for asking, Alex. All right, guys, that was 9 minutes. Does anyone have any questions or anyone still need more time?
I have a question on number 2 and 3. I got lost on number 2.
At what
Um,
point?
I did the first part, which was -5 times 8, then -3 plus 2 cubed. I put -5. I tried to refer back to the problem F that we did,
Uh-huh.
but I realized I got confused there because I don't understand. On practice F, I got 15, but I don't know where I got 15 from.
You're talking about over here?
Yeah,
You
so
know,
I got lost where I understand the -3 times 5 minus -2 plus 4 squared, or yeah, 4 squared. The part where I don't get is, when we bring down the 3 after we multiply it?
so the first step that I did is that right here on the whiteboard so far is I got rid of the absolute value, brought down the 8, and I combined the plus minus and got a minus. So this
Yeah.
is the next step. Okay, so you're with me. You're there, right?
Mhm.
And then are you stuck from here? Is that what you're saying?
Yes.
Okay. So whenever you get stuck, make sure you're following the checklist that we have. So are there any parentheses we can simplify inside?
No.
So we're done with P. Any exponents you can evaluate?
Yes.
Yes, which one?
2 cubes.
What's 2 cubed?
2, 6.
2 times 2 times 2.
Over 6. Oh, 8. I'm
8.
so confused. Oh, 8? Is it
Yeah,
8?
it's 8. Yeah.
Okay.
So it's 8. So plus 8 and bring down everything else.
-5.
So we're done with exponents. Now what's after the exponent step?
Multiplication and division.
Do you see any multiplication?
Yes.
Where?
8 times -5 times 8.
Which is?
40.
What kind of 40?
A -40.
Excellent. Bring down everything else. Do you see
Okay.
any other multiplication?
I get it now. No multiplication. Now it's the subtraction or the addition subtraction.
From which way to which way?
Left to right.
Excellent.
So it'll be -3 plus 8 or no?
Well, you don't do -3 plus 8 first. Which one should you do first?
-40 minus 3.
3.
And plus
That's
8.
what needs to be done first. Just because we add and subtract from left to right.
So it's -35.
Yes.
Okay, now I get it. And then for number 3, I did the steps as in we did for G for the practice.
So what'd you do first in 3?
For 3, I did -4, and then I did the parentheses first. Sorry.
And what'd you get in there?
I got 2, +2.
Good. And bring down everything else.
Yeah, and then I did I did the brackets -6 plus 5. I got -1.
Ah, so remember, when you're doing the inside of the brackets, you have to follow Pemdas. So when you're doing even the inside of the bracket gets its own Pemdas. So there's no parentheses inside Pemdas. There's no exponents in the brackets. So now what do we do first after exponents? We have to do all the what first?
Addition and subtractions.
No, multiplication and division. So what should you have done instead of add -6 plus 5?
Multiply.
You should have what?
5 times 2.
Multiply 5.
Yep.
That's 10. And then you bring -6 plus and then bracket it. Oh,
-6 and 10.
you subtract it. Oh, wait. Oh,
You add it.
We add it. Which is what? You owe me $6, but you're like, here's $10, Pacheco. +4. So then we bring down the -4 minus 7. What happens to these two 4s? What do we do?
Multiply them.
Which is what?
+16.
-16.
-16.
Bring down the -7, which simplifies to And you're done.
Well, I got that one wrong.
Did you see the difference from this work in your steps?
Oh, yeah.
Small mistakes?
It was a big mistake.
What'd you do?
Right there where you said that the brackets have their own steps,
Ah,
I missed that
I
because
see.
I wanted to ask you, what do we do within the brackets since the parentheses are in within the brackets? What's the difference? Because I didn't understand it, but I didn't ask, so I should have asked.
Now let's make a note. So no.
Note to self, ask
No.
questions.
So the note would be when an expression has multiple grouping symbols, apply order of operations from the innermost symbols going outwards, going out. Does that make sense? So we do the inside, the most innermost symbols first, working our way out using order of operations, which is Pemdas.
I have a question after.
Go for it.
Okay, so I know we have to hurry, but going back to G for the practice, I think I got confused with the part where I didn't write the step correctly because I put -2 and then the brackets. I got confused on. Yeah, okay. I missed that. I miswrote that step where it says -2 bracket -3 plus 10. I just skipped it to -7 or -2 and then the bracket 7. So I forgot to write that, which confused me. It threw me off.
Ah, okay. Always write the steps out. Note is the one thing I emphasize to write all these steps. As annoying and tiresome as it is, it's mainly for you to see, that's the recipe I'm following. So when you reiterate the same process, you can follow the same recipe. Not writing that step threw you off when you did it on your own. You see that? So be very careful with that. The only time I excuse you missing steps is if you fully comprehend and will remember the step that you missed, that you didn't write, that when you look at your problem, oh, I didn't write that because I know that in my heart and in my mind. Does that make sense?
Yeah.
But if you're still learning from the beginning, I expect you to write every step down so it can slowly click. All right. Do we have any other questions on any of these so far? Anyone need help with number 1? Okay, let's move on. Here is example 2, y'all. Let me go ahead and oh, not that one. All right, I'm gonna give you guys about a minute to set up the first example. A and B real quick. Or 2 minutes. I'll give you 2 minutes. Hey Vicky, that's a great question. I just saw your chat right now. You're asking if we'll have to be showing our work. No, ma'am, you will not. I do recommend on your homework when you all start working on my math lab is to have a separate journal separated from your notes with all the steps that you're doing to do it. And I highly, highly recommend that you do everything by hand and that you only use a calculator when you need it, but to try to practice these skills on your own.
Oh yeah, that's.
I agree, Mark. When I was a college student at undergrad, I had multiple colored pins that were erasable for my math notebooks, and I always had different colors for my examples, my steps. It was very colorful and organized, and it was really helpful. But it is tedious to start with, but it definitely makes an impact. All right, guys, let's look at this example. So the first two slides was about simplifying using order of operations. Now, this topic is about you're given an algebraic expression that has variables in place, and you're in charge of the values that they give you for you to plug in and evaluate and to get a number using your Pemdas. All right, so let's look at A. So A is saying x squared and negative x squared for x equals 11. Negative 11. So what they want us to do is they want us to plug in negative 11 for x for both of these expressions. So let's do x squared first. So x squared equals, remember, now a word of advice, whenever you're substituting something into x, you want to put it around parentheses. So it'll be parentheses negative 11 squared. So then that substituted the x, and we know when we see it like this, my base is a negative 11. So I'm gonna do a negative 11 times a negative 11. And two negatives make a what?
Positive.
Positive.
And then we have 121 for 11 times 11, and we're done. Now we're going to do the second expression. We're going to do negative x squared now. So now the negative is there, parentheses, negative 11 squared. There's a negative outside of x. So do you see how it looks like the exact same thing from the top, but it just has an additional negative sign? You see that? So now we're going to evaluate this. So this is the same thing as negative 11 times negative 11. Well, let's see what that simplifies to. Well, let's ignore the numbers and focus on the signs. A negative times a negative is a what?
Positive.
Positive.
Times a negative?
Negative.
It goes back to being negative. Y'all see that?
Yeah.
And now we're gonna do 11 times 11, which is just 121. So the answer for this expression is negative 121. Does everyone see that?
Yes.
Excellent. Now let's look at B. B gives us one expression, but it gives us two different z values. So we're going to do 6z squared. So we're going to do z equals 2 first. We're going to do the positive 2 first, which is 6z squared. But wherever we see a z, I'm going to plug in a positive 2 and make sure that you put parentheses around the value 2. So which number is being squared, guys? The 6 or the 2?
2.
What's 2 squared, y'all?
4.
What's 6 times 4?
24.
And we are done. Now we're going to plug in z equals negative 2. We're doing this one now. So it'll be 6z squared equals 6 parentheses negative 2 squared. Now what's being multiplied? What's my base now? What's being squared?
Negative 2.
What's a negative 2 times a negative 2?
Negative 4. Positive 4.
+4. So then we get the same thing as 24 and we're done. Any questions for A and B so far?
Am I able to copy this down real quick?
Yeah, can you?
Say that one more time.
Can we copy these down for examples?
Yeah, of course, of course. Let me give you 2 minutes and then we'll get started, okay? All right, guys, am I able to start on C and D real quick? Or are you still setting up?
We have 1 more minute.
Yeah, 1 more minute. I got you. All right, guys. Hopefully that was enough time to set up your C. I'm gonna get started on C. So C, the expression is x plus 2y minus z for when x is 3, y is -5, and z is -4. So you can always color coordinate as you like. Notice how I'm just only messing with the letter. So for x, I'm gonna put parentheses 3 plus 2 parentheses -5 minus parentheses -4. Notice how there's parentheses over every value that we plugged in. Now, sometimes the parentheses will matter. Sometimes they really won't. And I'm gonna tell you right now, the parentheses does not matter for one of these variables. Which one can we drop the parentheses right away?
The +3?
Yeah, the +3, because there's nothing going on to that 3. That 3 is plain and basic and just ready to just come on down. and enjoy the world of life. Now we have the +2 parentheses -5. Now, we have a minus a negative. What happens when we have a minus and negative together? What
It's a
operation? It becomes a what?
positive.
It becomes a +4. And once we know it becomes a +4, we can drop the parentheses because it's the same thing. So two negatives is the same thing as a +4. Is everyone with me? From here to here. So all we did is plug in the numbers that we had here into the letters. We dropped the parentheses and simplify where we could. So now we're going to go ahead and simplify using Pemdas. So there's no parentheses, no exponent,
It's multiplication.
multiplication. 2 times what?
2 times -5.
Which is?
-5.
Nope, not -5, negative
10.
-10. And now we add and subtract from left to,
Right?
which is, what's 3 minus 10?
-7, yeah.
+4?
11,
Look at the numbers.
-11.
So do you have $7 in your account?
-3.
No.
It's -3. Does everyone see why it's -3?
Yes.
All right. We're on the last question, guys, of this slide, the last question of this slide. So we have 7 minus x squared for x equals -4. So it'll be 7 minus parentheses -4 squared. So let's use our Pemdas. So there's no parentheses simplify. Do we have an exponent?
Yes.
Yeah.
Mm,
What does that exponent simplify to? What is -4 squared?
It's negative or positive 16.
Yeah, it's a -4 times a -4, which is a +16. So this becomes 16 positive. Bring down the leftover, the 7 minus. So now we simplify by combining these two. What's 7 take away 16?
-9.
And we are done. What questions do we have for any of these examples?
Where did we get the 16 from? On
Remember, so we did Pemdas and we did the exponent, and the work is over here for the exponent.
oh,
Now you could do the work in your steps over here. I'm not judging you, but I'm just showing you how we do it in as mathematicians, so you can pick up these habits too. They're kind of useful, but if you like to do the work in your lines, that's fine too. Just make sure it's not messy and we can understand your handwriting.
okay.
Any questions so far, guys? All right, now due to the time constraints, guys, unfortunately, we won't be able to do these practice problems for this part, just because I want to get through because we do have another section to do. So I do want to just push through it. So these are the practice problems. If anyone wants to take a picture with their phone, so you can work on these at home outside of after class today, you can. And you can always email me a picture and be like, hey, Pacheco, this is what I did for the practice. The one that we didn't do in class. Are these right? I felt good. I felt bad, and whatever.
Okay.
And remember, I will be posting these videos sometime today, tomorrow, the latest. And it's going to be a YouTube channel from now on, just to keep you on mind. All right, anyone need more time to take a picture of this? Anyone? All right, go ahead and write all the way until I'm gonna give you 2 minutes or 3 minutes to set up all of the top part of this slide, and then we'll get started on the work, okay? Give you 2 minutes.
Sir, you're still recording, correct?
That is correct.
Okay, thank you.
All right, is anyone still setting up this example or on their notebook still? Okay, I'm gonna go ahead and begin. Oh, Sean, yes. Okay, I'll give you all an extra minute. All right, guys. So finding averages. This is the last topic for the same for 2.5 before we do 2.6, guys. So finding averages is an average equals the sum of numbers over the number of numbers. So a sum means pretty much when you add all of the numbers, and the number of numbers is just a quantity, the number of them. So then we have the plus sign for sum. So look at the example. The graph shows some monthly normal temperatures for Barrow, Alaska. Use this graph to find the average of the temperatures for the months January through April. So we want to find the average of January through April. So how many months is that?
Or
4. So we're going to find the average. We're going to add, we're going to make a fraction bar. So average, I make a fraction bar. And we're going to add all the months on top divided by how many months we added. So we're adding 4 months up. So we're going to have negative 13 plus negative 16 plus negative 13 plus 2. So now let's add up the numerator. If you owe the bank 13 and you spend another 16, how much do you owe? for
Negative
this?
3.
You sure? You already owe 13,
Oh,
but you spent 16 more.
29. Negative
Neg-
29.
Negative 29. What's negative 29 plus negative 13? You spend another 13. So now what do you owe?
Negative $42.
So we have negative $42. But guess what? You found $2 on the floor. So it's negative 42 plus 2.
Positive 44.
You look at it.
44.
Negative 44. But you found $2. Negative, negative 40 over 4. Because it's not enough to pay it off. So it's you're still gonna owe the money.
Oh,
Just-
okay.
So then
Okay, negative 10.
so negative 10. So that is the average. The average in Barrow, Alaska in winter and early spring is negative 10 degrees.
Jesus Christ.
So that's how you yeah. That's how you find the average of things, guys. So let's say you want to know the average that you're spending every month. So January or today October, right? So let's say October, November, and December, these 3 months, you take how much you spend in fast food and you add them all up, divided by 3, and that is the average of what you spend each month. It's just a way to kind of look at data. That's what average is, okay? All right, guys, we're starting the second and last lesson of today. I'm gonna go ahead and give you about 3 minutes to write this slide down. All right. We don't have much time at the same time as before for the first lesson. We take a little longer than I thought. So I'm not gonna try to rush you, but let's just try to get through this. Okay. Ask any questions you have and let's get it. So I'm gonna give you 3 minutes.
what do you want us to do with this? Write it down.
Yes. Write the title of the section and then write what you see. All right, guys. Does anyone need an additional minute or two to finish copying the slide down?
Yes.
Okay. All right, guys, so I'm gonna go ahead and start talking about this slide. So this section 2.6 is about solving equations. It's about the addition and multiplication properties. So what is an equation? Well, last class we talked about what is a solution to an equation, right? And how to check if it is. We check it by plugging it into the equation to see if we get a true statement. Now, here, what is an equation though, right? What makes an equation an equation? Well, an equation is pretty much when you have two different expressions equal to each other. Hence the word equal, equation, and the equal sign. Well, look at the note that I wrote in the bottom in pink. I wrote that x equals 4 can also be written as 4 equals x. Just kind of highlighting that the pretty much that equations are symmetric. That a equals b is the same thing as b equals a. It's the same thing. And it's the one thing that I need you guys to understand that because that may help, that may benefit us in the long run as we do more of these examples in the lesson. Now, another thing to denote is it's like a left side and a right side. So an equal sign means that these two expressions are equal. And in order for you to understand what that means is imagine a balance beam, guys. Imagine a balance beam in front of you. And if you have 10 pounds on one side and 10 pounds on the other side, it will stay equal, right? Because it's balanced. Now, if you were to take away 5 pounds to keep it balanced, you're gonna have to take away 5 pounds here too. So what you do to one side, we're gonna have to do to the other to keep it symmetrical and consistent. So what does that mean, right? Well, here is another helpful hint. So I'm gonna go ahead and give you guys about 3 minutes to write this helpful hint down. And example one, guys, I'm gonna give you 3 minutes. Now we've done this examples once in 1.8 last class. So look back, have you finished writing this in ahead of 3 minutes? Try to do number one by yourself, example one. See if you can determine if this is a solution looking at the last lesson. Good luck. All right, guys. So let me read this over this helpful hint. So simply stated, an equation contains an equal sign while an expression does not. Also, we simplified the expression and we solve equations. That's the difference that we do. So look like example 1. Determine whether -1 is a solution of the equation 3y plus 1 equals 3. Can someone share with the class how we would determine that? What do we do?
You do 3, plug in -1 as your y, so it'd be 3 parentheses -y parentheses again plus 1 equals 3. And then it would be, you'd multiply those two, so you'd multiply 3 and then parentheses -1, and then you get 3 by itself with the negative, and then plus 1. And then I got it's not true that it's not a solution because -3 plus 1, I got it was -2. Yeah.
And it don't equal, and since it's false, we can say that -1 is not a solution. Does everyone understand that procedure and the process, guys?
Yes, sir.
All right, try that practice problem on your own. I'm gonna give you 2 minutes. Good luck. It's right there, practice 1. And write in the chat if you think yes, it's a solution, or no, it's not a solution for -2 in the given equation, guys. Yes, it is, or no, it isn't on the chat after you checked it yourself. Excellent, guys. Good job, class. The answer is correct. It is a solution. It's true. Awesome. Anyone need me to work out the practice problem? All right, let's move on. And here is your first property of elementary algebra. So go ahead and write the addition property of equality, and I want you to put a box around it, and just pretty much like, this is the first property I'm exposing you to. Write it the way you see it. I'm gonna give you about 3 minutes to set up the property and example 2, okay? Then we'll get started after 3 minutes. Good luck. All right, guys. So is anyone still writing this down in their notebook, guys? All right. So the addition property of equality. Oh,
I think
yeah.
opposite.
Okay. Okay, yes, Shannon. Okay, I'm gonna go ahead and give you guys an extra 2 minutes, okay?
Sir,
Yes.
let me know if I'm reading this right. Solve x -2 equals -1 for x,
Mm-hmm.
because that for me does not make sense. So
So
go ahead.
so you said x -2. It's kind of not accurate. You rather say x -2.
Okay.
X -2 equals -1. So whenever the negative symbol is between two characters, like a variable and a number, it's a minus. Whenever the negative is by itself or it starts off with it, like the one, it starts off on the right side negative, you can say -1 instead of -1.
Okay. Okay, so I was reading it wrong.
Yes.
Okay.
All right, guys, I'm gonna go ahead and start reading the property. So what this property says is let A, B, and C represent numbers. Then when you have A equals B, then when you add A plus C equals B plus C, they're equivalent equations, which is saying is if we have an equation, we can add something to one side as long as we add it to the right side. And it goes the same thing with subtraction. Whatever we do to one side, we can subtract the number along, and as long as we do it to one side, we do it to the other. So you're probably wondering, well, what does that tell us, Mr. Pacheco? What can we do with this property? Well, this tells us that when we have x -2 equals -1, that we can manipulate this equation using this property to our benefit. Well, the question is probably, well, how can we manipulate it to our benefit? Well, what this equation is saying, everyone, it's saying that x -2 is equal to -1. It's saying that two numbers subtracted, x that we don't know -2 equals -1. So we can guess x number. We can say x is 5. 5 minus 2 is 3. Nope, it's not. X is not 5. We can guess, but that's going to take too much time and too much energy. That's why the invention of algebra was created. So there is a procedure of what we can do mathematically to manipulate it to get x by itself. So the first thing you do is draw a line down the equal sign, and we look at the x value. We want x by itself. We want to move the -2 to the other side. Well, ladies and gentlemen, in algebra and math, what is the opposite of -2?
Positive.
+2. So we're going to do a +2 underneath. One second, my board just went out. Give me a second. So then we add 2 on both sides, +2. Because what we do to one side, we do to the other because of this property equality. Now, -2 plus 2 is 0. So you're going to draw a 0 with the line between it and bring down the x. X is now alone. Look at the right side, -1 plus 2. If you owe the bank $1 and you put in $2 into your account, how much money do you have to yourself?
+3, no.
Negative
No,
40? Oh,
no. So you owe $1. You owe $1 and you put $2 in.
+1.
Oh, yeah.
+1. Does everyone see that?
Yes.
Now you're probably wondering, well, Mr. Pacheco, how do I know if this is the right solution? What if I don't know if I made a mistake? Well, I'm going to show you how to check your work. And since all of you guys are beginners in mathematics, I expect all of you to check your work, even if the equation is super simple. Is that understood?
Yes.
So, and guess what? We checked this the same way we determined if this was a solution. What did we do to this number to check if it was a solution? We did what?
You put it in the problem.
We put it in the problem. So where am I going to plug in number 1 at?
Right
In the
back.
problem.
In the problem. So instead of x minus 2, we're going to write what?
1 minus
2 equals
Equals.
-1 with the question mark on top. It is imperative and important that you put in the question mark on the equal sign so you know, hey, I don't know if this works out. Let's check it out. So let's simplify the left side. 1 minus 2. If you had $1 in your account and you spent 2, what do you owe the bank?
-1.
So then we get -1 equals -1. True or false?
True.
So is 1 a solution?
Yes.
Yeah, we got it right. So this is the techniques I want you to practice after this lesson when you start the assignments. So let's try a couple more before we do the next property. All right, I'm gonna go ahead and give you guys 2 minutes to set this up in your notebook and then we'll get started, okay? Now, if you want to try to do this on your own, seeing the step we did last, you can, but you don't have to. You can wait for the timer.
Can we, like, when a problem is backwards, can we write it how we want to write it? Or no?
Yes. So first write it the way I gave it to you, but I want you to, I like where your head's at. That's what I showed you this property. That's why I told you A equals B is the same thing as B equals A. And this note, that's why I wrote the note, X equals 4 is the same thing. So that means you can flip the equation to your benefit. So I'm not going to tell you what to do, but just know that you could do it. All right, guys, that was a 2-minute timer. Let's look at example 3. Solve -a equals n plus 1. So I'm going to go ahead and rewrite it. So -a equals n plus 1. I'm going to draw the line down the equal sign. What letter do we want by itself in this example?
And
What's happening next to the n that we need to move over?
the 1.
How do we move a +1 to the other side?
Make it a
So-
negative.
Make it
Yeah.
a negative. And what we do to one side, we do to the
Other side.
so these 2 ones become 0. I don't want you to say cancel out. I want you to say they zeros out and bring down the n. -8 minus 1. You owe $8, but you spend an additional dollar. So how much do you owe the bank?
-$7.
Negative 9.
I heard -7 and -9. Which one?
-9.
-9. That's correct. But I don't really like the way this looks. So based off of the property, the note I told you, how else can we rewrite this?
You can check it by doing 9 plus
9
Oh,
times
N equals
1.
-9.
So we can rewrite it as n equals -9. These two mean the same thing, but now I'm gonna check. So let me switch up my color off. So to check, we're gonna plug it into the problem, right? So I'm gonna plug it into the original problem. So we have -8 equals question mark. Instead of n, I'm gonna write -9 plus 1. Now we're not gonna simplify the left side since it just has a number by itself. Can y'all tell me what -9 plus 1 is?
Negative.
Negative 8.
Yeah. Is that true or false?
True.
So we got the correct solution. Do y'all see how that check component allows us to determine, hey, I got the right answer without even having to ask me, without having to, use an app or cheat. You can check your own. This is why I find math to be such a beautiful subject, is because you can keep yourself in check as long as you're following the rules you're learning in class. Now, example 4 is slightly easier because x is already by itself. So what do we have to do on the right side with all these values?
Check
X,
it.
we just not check it, but just simplify it. How do we simplify these three? By just what? We add from left to.
Right.
So what's -60 plus 4?
Negative 56.
Bring down the
Negative
plus 10.
56.
Correct. And what's -56 plus 10?
Negative 46.
There you go. And now checking's going to be a little odd, but it's the same concept. You plug it into the original. So you get -46 equals question mark, -60 plus 4 plus 10, which we know is going to be -46. And you can always double check using a technology, a calculator. So we're good to go, guys. It's true. Are there any questions before I have you practice these on your own? All right, here is your 3 practice problems, guys. I'm gonna go ahead and give you 5 minutes on these 3 problems, okay? Starting now. Good luck. All right, guys. So that was a 5-minute timer. Anyone want to talk about it? Ask any questions about these equations on
Uh,
what to do?
I'm confused on like the negative and positives. For number one, I got that it was 4, but I don't.
What did you do? Did you check it to see?
Yes, but I don't know. Like, this is the part I'm confused on. I did y minus 6 equals -2. And then I brought the 6 down because we're trying to find y by itself.
So how did you bring it down? What did you do to the
I
equation?
don't know if it's a +6 because I put +6. And then I did +6 on the other side. And then I got 4 positive. And then that canceled out. And then to check the work, I did 4 minus 6 equals -2. I
Which
don't
is
know.
true.
I don't know whether if I put +4 on the bottom when I check my work, or I put -4 checking my
Well,
work.
all you gotta do is just check in your notebook. Check, did you write 4 minus 6 equals -2? If you did that, then you're good. You put in +4. And then 4 minus 6 is -2 equals -2. So you're good to go.
Oh, okay. I did an extra step that I didn't need.
I did the opposite. I put the -2. Oh, +2.
What do you mean? What did you get for the answer?
I got 4, but I got -4 because I took the 2 and I put it underneath the 6.
Ah,
I
okay.
did the same thing.
Okay. But does everyone see that it's +4, right? And then how you check it, how it's 4 minus 6. Everyone good with that?
Yes.
Okay. All
And
right.
then
So
Any-
how do you know which one's gonna be like gonna go down to get multiplied or added or something?
It depends. You're asking like what are we gonna plug in? Kind of, is that what you're asking?
Yeah, like how it's +6. How do
How
we
to know what to put?
Yeah.
I think he's asking which side we're gonna be working with.
It all depends on where your variable is at. So right here, the y had a -6 next to it. So we want y equals. We want to get to y by itself. So how do we move a -6 to the other side? So to manipulate an equation we established, we have to do the opposite operation. Here, the opposite of -6 was what? +6.
Plus,
Okay.
because I put negative for mine, but okay, I got him.
Because if you now think about it, I want you to see something. Let's pretend like we didn't know, right? Let's pretend that we had -6, right? And then we put another -6 here because we didn't know, right? We're not comfortable with this yet. So what happens if we do the same sign? Well, let's do the same. Let's simplify. -2 minus 6 is -8. Now, what's -6 minus 6? Does this cancel out the sixes?
mhm.
This cancels out -6 and -6.
No.
No, it gives us actually -12. So you see what I mean? So that's how, when you know something doesn't cancel out, that means the step was incorrect. Does that make sense, Mark? What step to do? It depends on what's there. Like, look at number 2. What's next to the Z?
-2.
+8, right? Well, you know what? You know how the Z this way? Remember, we can switch the sides, so we can actually rewrite it like this if we wanted to. These mean the same thing? Everyone understand that, right?
Yes.
So now look at the Z. What's next to the Z that we need to move over?
The 8. So it becomes -8.
+8.
How do we move a +8?
You can do a -8
We'll
on
make
the
a negative.
A -8. Does everyone now see how that's the opposite? And these are gonna cancel. So
Yeah.
draw your 0,
Yes.
bring down your Z, and then combine and move on. What would y'all get for number 2?
-10.
That's correct.
We're -10.
Good job, good job, good job.
Yeah, I got that one.
Okay, what about number 3? Do we have to move anything to the other side?
No.
No, we just kind of combine the things to the right side, right? So let's combine. What's -2 plus 90?
88.
So you have
Negative
88 plus negative 100. I heard negative 88. Are you sure? Look at the talk about money. Do you owe $2 or do you have $2? You owe. Now, do you have $90 or do you owe 90?
you own
You have 90 because it's what?
plus.
Plus. Y'all with me? Y'all with me?
Yeah.
So when we add those two, we get 88 and then bring down the negative 100. What happens when we have a plus a negative? What operation does that become?
Action.
A subtraction problem. So then we do 88 minus 100, which is what?
-12.
Yep. And then we're done. Before you check though. Now for this type of problem, number 3, when you're checking it, I would just pretty much use your calculator to do -2 plus 90 plus negative 100 or minus 100. And you will see that you get -12 equals -12, which is true.
Sorry.
You're okay. All right. Are there any other questions on these practice problems, guys? Any questions? All right, we have the last property and we have a couple more examples and we're done, guys. So I'm gonna go ahead and give you guys about 5 minutes to copy this property and example, okay? All right, guys. I'm going to read over the property. So the last property allowed us to subtract and add to the equation to manipulate and move things around. This property allows us to multiply and, excuse me, and divide as long as what we do to one side, we have to do to the other. Now here in this property, it talks about how times C, we can multiply a number on both sides and it keeps it equivalent. Just like here, we get to divide another number as long as that C is not 0. That's very important here. So now you're probably wondering, well, how is that going to help us, Pacheco? Well, let's look at example 5, everyone. Solve negative 5x equals 15. Now, we explained this in other lessons. Can y'all tell me what operations going on between the -5 and the x, guys?
Multiplication.
We are multiplying. So what is the opposite of multiplication, guys?
Division. So you're gonna divide negative 5x on both sides.
Yes, but not x.
Positive.
We're only going to divide -5
Mhm.
because we want to get what by itself?
The x.
X. Now, remember in the last example, I had you guys put a 0 whenever we subtracted or added because it's zeroed out. Well, here we're not gonna zero it, we're gonna put a 1. When we divide the number to itself, it equals to 1x. But remember, 1x is the same thing as x. These are the same thing. So we don't have to write the 1 all the time. But this is gonna cancel that or get rid of the 5s. Now we just gotta divide a positive divided by a negative. What's a positive divided by a negative?
Negative
Good. How many 5s go into 15?
3.
And we are done. Now we want to check them out to make sure we're good, right? Because what if Pacheco isn't there to help us? Well, how can we check our solution? Remember, we plug it into the original equation. So we get -5 parentheses, -3 parentheses equals 15 with the question mark on top. And now we simplify. What's -5 times -3?
15.
Does 15 equal 15?
Yes.
So we are correct. Are there any questions on how we use the property to solve this equation? All right, let's expose ourselves to a couple more examples before I have you practice the last topic, okay? We're almost done, guys. We need this and 2 more slides to go, all right? So I'm gonna give you about 2 minutes or 3 minutes to write down 6 and work on 6 and try to do 7, all right? 3 minutes starting now. Good luck. All right, guys, for example 6, we have negative 27 equals 3y. What operation is happening with the 3 and the y?
Multiplication.
So how are we going to manipulate it to get the y by itself?
Divide by
Divide 3 by both sides.
Divide 3 by both sides. That is correct, y'all. We get a 1, right? So draw your 1. What's by itself now on the right side?
3, negative 27.
Negative 27 divided by
3.
how many 3's going to 27?
9.
9.
9,
It's gonna
negative
be
9.
negative 9. And if you want to rewrite it the other way, we can write it as y equals negative 9. Now remember, you know how to check your work in case you're not sure, right? So we do check. And when we plug that in, how would it look like when we plug it in?
It's going to be 3 parentheses negative 9 parentheses equals a question mark above negative 27.
That is correct. Now we simplify it. What's 3 times negative 9, y'all?
Negative 27.
And does that equal negative 27?
Yeah.
Yeah, so it's true. So did we get the right solution?
Yes.
Yes, we did. Last one, example 7. We have negative 12x equals negative 36. How do we get x alone, ladies and gentlemen?
By negative 12 again, and then
Divide by negative 12, correct. What we do to one side, we do to the,
other
Positive 3.
what kind of 3?
Negative 3?
positive 3.
Look at the signs. What kind of number is 36?
And negative 36.
And negative, and 12 is negative. And 2 negatives make a
Positive.
positive. And then we get a 3. We're not done. Let's check our work. So then we get negative 12 parentheses 3 equals negative 36 with a question mark. Simplify, what's negative 12 times 3? Negative 36, which is true. So it is a solution. Any questions on example 6 or 7? All right, guys, we have one more example and then we have one last set of practice problems and we're done with today's lessons, okay? So example 8, I'm gonna go ahead and give you guys a minute to set this up and then I'll work it out. I'll work through it. All right, let's take a look at this example, guys. So here we have x over 3 equals negative 2. What operation is as another way to describe a fraction, y'all?
Division.
Is division. And what is the opposite of division?
Multiplication.
So we're gonna multiply 3. And what we do to one side, we have to do to the what?
Other.
And now remember, there's multiple ways to write multiplication. You can write a dot or you can do a parentheses. I'm doing both to show you that we have flexibility when it comes to the multiplication. So then we're gonna multiply this 3 times x over 3. So make 3 into a fraction over 1. 3 times x is 3x. 1 times 3 is 3. And then negative 2 times 3 is negative 6. Well, we know 3 over 3 is just 1, so we can just write 1 through that. So we get x equals negative 6. Now to finish this off, we just plug it in to check. So we get negative 6 over 3 equals negative 2 question mark. Negative 6 divided by 3 is a negative 2, which does equal negative 2. So it is a true statement. So negative 6 is the solution. What questions do we have on this example when it's a dividing a number? All right, let's go ahead and see how you do on your last set of practice problems. I'm gonna go ahead and number them real quick. This is number 1, 2, 3, and 4. As y'all do this, guys, I'm gonna go ahead and do roll call for attendance. 1 second. I remember, let me know that you're here, guys. Isabella, Alanis. Isabella, you here today? How about is it Alina? Alina Andrade?
Yes.
Okay, awesome. Chris Potran.
Here.
Jasenia.
Here.
Awesome. Jennifer Cavazos.
Here.
Lydia. Last call for Lydia. Lydia Coffee. Monica De La Rosa.
Here.
Sean. Gabriela Estrada. You always type it in the chat, guys. Is Gabriela here?
Said yes.
She said yes. Okay. Awesome. Mark.
Here.
Damien. Damien Garcia. No Damien? Isaac Garcia. No Isaac. Savannah is working. Melanie. Alyssa.
Here.
Matthew.
Here.
Mario.
Here.
Vicky. Excellent. Alex.
Here.
Catherine. Jose.
Here.
Rosemary.
Here.
Johnny. Is Johnny here? No, Johnny. Josh, what? I see you.
Here.
And Ariel.
Here.
Ariel's not here, right? Ariel Zuniga.
I'm here.
Oh, okay, my bad. Okay, I didn't hear you. My bad. All right. So no Johnny, no Savannah, no Isaac, no Damien, no Lydia, and no Isabella.
You forgot about me, Mr. Pacheco.
Who did I pronounce?
You forgot Melanie Hartman.
Oh, I got you, Melanie. Yeah, yeah.
Oh, okay. I
Yeah,
was
yeah,
like,
yeah.
I was waiting for my names to say here.
No, no, yeah, yeah. I marked it down since you were participating a lot. I got you. You're good.
Thank you.
No, thank you. All right, that's everyone. All right. And feel free to type in your solutions on the chat to see if other people got the same thing, guys. Compare and stuff. All right, excellent stuff, guys. I'm seeing you guys writing down your answers or talking about it. Anyone getting stuck on any of the equations so far? Which one do y'all feel is easier? The multiplying, the dividing, the adding, or the subtracting? So y'all
The
been
dividing.
the dividing? Nice.
Dividing.
That's cool. That's good to hear. All right, that was my timer. Is anyone still working on any of these so far? All right, guys, if no one is still working through these practice problems, I'd like to go ahead and um I'll give you 2 more minutes, and then I want to make sure we can all get access to my math lab this afternoon. Now, as for tutoring, guys, I'll try to set up some time tomorrow or Friday, but it's going to be very tough with what I have going on outside of work and stuff. So I will try to set up some tutoring sessions, but I do highly recommend that you guys take advantage of the free tutoring services online as well. On the Canvas page, there's also a tutoring link as well to virtual tutoring as well, if that's something you want to utilize. But I do not mind helping as well. But I also do want you to guys utilize the free resources that come from you being a student at Alamo colleges, okay? But we'll get through that in just a moment. So after my timer runs out, I'll ask if there's any questions. I'm gonna go ahead and wait, and then I'll stop recording once I'm no longer working on the math. So. All right, guys. Anyone have any questions for me regarding this lesson, my class, or anything before I stop the recording?
No.
All right.